your model. There are several tests you can do after you've obtained your model. There are several tests you can do. I'm not going to discuss all of them. I'll discuss only 4, probably even 3. The first one is, should we apply pooled OLS? That's the first thing. Should we use pooled OLS? There's something we call POLS test. The POLS test will help you whether we should use pooled OLS, and we're going to do that now. What it does is that it tests the null hypothesis that the same coefficient apply to each individual. And this is pooled OLS. Should we use pooled OLS on the data? Let's see. The null hypothesis is that the data is poolable. That means that the pooled OLS is stable. The alternative hypothesis says that the data is not poolable. In other words, don't use pooled OLS. Don't use pooled OLS. That's what the alternative hypothesis says. Okay. If the p-value is less than 5%, we always will reject the null hypothesis. When you are rejecting the null hypothesis, what you are saying is that you should not use pooled OLS. So you conclude that pooled OLS cannot be used, and you need another variable, which is one of the fixed effect, random, any of the variable coefficient model. Now, you need, because he was telling you that the coefficients are not variable, they are the same. That's what pooled OLS said, the coefficients are the same. Now, if you reject that null hypothesis, then you say that the coefficients are not the same, they are variable. So, how do you do that? Well, this is a command to do. Invoke the library PLM if you have not already done that. Then you type into R your POLS test, the log of the wage, everything as it is, okay. And then run your within model, okay, which in this case is the fixed effect model. I'm using smaller number of independent variables because this one will work better. Okay. If you use smaller number of independent variables, you're going to have the p-value to be 1. We can use the pooled OLS here by typing pooled, but we are not using all the variables, as you can see here, for simplicity, for a reason. Because when you go and use the one with all of the variables, this command gives us some issues. I don't know why the issues, but it looks to me that when there are a number of the independent variables, especially the time dummies, this is just a test you're doing. Then you have those issues. So let's go and check. I'm going to do this one in R, and then we can now check the poolability. Should we use pooled OLS? This is a poolability test. Okay. And this is it. Okay. It can take some very long time. Okay, so this is the results. So the result is that the p-value is 5.2%. 5.2%. So if it is 5.2%, what does that mean? If it was less than 5%, then we will say that don't use the pooled OLS. But now that it's 5.2%, it means that it is possible to use the pooled OLS. You're kind of on the margin. You're on the margin. So there's nothing wrong using the pooled OLS to make your decision. Guys, let me just remind you of the pooled OLS. It wasn't that bad. I'll put it all in the table later. But let me just remind you of the pooled OLS. It wasn't that bad, especially when you use the pooled OLS and correct for the heteroscedasticity and autocorrelation using the NOAA West. This was it. This was it. It wasn't bad. It wasn't bad. It wasn't bad. It wasn't bad. So please note that. Given this, I would have juxtaposed the pooled OLS and use it for my interpretations alongside any other good model if I check. But please note, it doesn't mean that pooled OLS is your only thing that should be used. Now we have to go and compare the pooled OLS with another model. Okay? With another model, we'll come back to that. But for now, checking whether pooled OLS can be used, it is clear that it can be used. The next test is to test for the individual and time effect. Okay? Is there some individual factors that are causing effect in the model? Is time affecting the situation? So the null hypothesis is that the unit fixed times make no difference. Okay, so the fixed effects, the individual specific effect, they make no difference. Okay. The unobserved heterogeneity don't matter. And then the alternative is say that, hey, hang on, there are differences between the individual firms. Sorry, in this case, individual workers. Okay. You can also formulate a time effect one. Okay. If your focus is to check whether time even has anything to do with the whole model. And in this case, you use something we call the Lagrange multiplier test of individual or of time factors. And this is based on the pooling model. Okay, so how do you do that? Well, this is how you do that one too. Once you've estimated the whole thing, which in this case is a pooled mode, then you use a PLM test for that. Okay. Now this PLM test, okay, it will be adopting the Bruch-Pagan test. It will use that Bruch, and there are several other ones you can use. Okay, the type can be Bruch-Pagan. You can also use another type, which is GHM. It's from these guys, okay, Gorearox, Holy, and Mumford. Or you can use another type, which is Kin and Wu. All of this, you have to read them on your own. Okay, you can change the effect type anytime. You can change the effect type to individual or to time. Okay. And now let's run that and see. Let's go to our R to see whether time matters or individual specific factors matter. This is it. And this is it. Okay. Oops. I hope you guys can see the results. So the one I used was a GHM. You can see it in my own, that I use the GHM. Okay. That is what I use. Now, if the null hypothesis is less than 5%, sorry, if the p-value is less than 5%, you reject the null hypothesis. Now, in our own, the p-value is truly less than 5%. So you reject the null hypothesis that says that the individual factors don't make any difference, or the time factors don't make any difference, because believe me, they make. Now, in this case, which one were we doing? We're doing both effect. So we're saying that whether it is individual or it is time, both of them matter because the p-value is 0. It's less than 5%. And because the p-value is less than 5%, we can now conclude that individual heterogeneity matter. That is why when you run the fixed effect, you can add the two-way fixed effect, or times fixed effect and then individual fixed effect. You can add it. You can add both of them because they matter. They matter. And according to this one, they do matter. They do matter. All right. Let's go to the last test. Last test that we'll do to indicate. It's not the last but one. And the last test is probably the most critical test, important one, is a Hausman specification test. So the Hausman specification test is done after you've estimated the random effect and then the fixed effect. And then you use it to tell which model you are going to use to make your illustrations. Under the null hypothesis, both the random effects are consistent, but then the random effect is more consistent because it has a smaller variance than the other one. Okay. So we use this test. This test is sometimes called Debin-Wu-Hausman specification test. That's what we do. And it's very important to know how the test is done. Okay. So I decided to give you the test statistic here because it's very nice to write it in your paper when you're writing the test. Okay. The test statistic is given by H for random, for Hausman. And what the test is doing, basically, if you check carefully, is that it is checking the difference between the random effect parameter, the random effect beta parameter. Okay, the difference between that, and there are variances as well, the difference between that. Okay, So this whole thing can come below because of to the power -1. It can come as a denominator. So the variance of the random effect and then the variance of the fixed effect. And this is chi-square distributed. Okay. So in other words, it's not normally distributed. Now, when the difference in the variance is not positive, definite, okay, then we say that a Maury-Penrose generalized inverse is used. And Maury-Penrose generalized index is the chi-square distribution that you see. It's a chi-square distributed with the degrees of freedom equal to the number of coefficients for the time-varying regressors. For the time-varying regressor, not any regressor. If the Hausman specification is insignificant, that is the p-value is bigger than 5%, then we use the random effect. But if the Hausman, the p-value is significant, then we use the fixed effect. If it is significant, you use a fixed effect. If it's not significant, we use a random effect. So we are going to run that. Okay, let's go to our R and run that and see the situation. So this is a Hausman specification test. Please, this test is just a test of between random and fixed effect. Okay. That's a test. So I already have my WR, the random estimator. I've estimated, a fixed estimator I've estimated. And then this is the result. Who can tell me, based on the results you are seeing here, are we going to go for random effect or we are going to go for fixed effect? Oh, this one you can type the answer. This one is a very simple. Are we going to go for the fixed effect or we are going to go for the random effect? Which is more appropriate here? Now, in this case, the p-value shows that the Hausman is significant. So which effect is this? Let me see. Exactly. So it means that for all this model we have been using, this wage pound model, we are dealing with a fixed effect model. Now, I will tell you for sure that even though you have a fixed effect model, have a random effect in the table. Have a random effect model in the table. And then don't speak of the random effect, just speak of the fixed effect. Just speak of the fixed effect. And of course, remember we had our pooled OLS. We'll come back to that. Okay, come back to that. So, but for this purpose, random effect is a winner. Please note that the Hausman test is often used when choosing between OLS and two-stage least squares as well. Two-stage least squares. You won't get it. I've done a video later, you can watch it for your own joy. It is for instrumental variable regression. The two-stage least squares method, it's used to estimate linear regression model, which incorporates instrumental variables in the model. And it's very good for dealing with endogeneity. By now you all know about endogeneity. But for our purpose, fixed effect is a winner for this. Let me take you to the final test. I said that Hausman was final, but it wasn't a final. This is a final. A final is known as Greuch-Pagan-Lagrange test. You remember we compared the fixed effect and the random effect. Now we are comparing the random effect and the POLS, the pooled OLS. So suppose you are battling with which one should you use between the random effect and the pooled OLS? Which one? Well, this is the instruction. If the LM is significant, if you do it, and then the LM is significant, then you are going to use the random effect. So we are going to run it. And if we realize, if you run this Greuch-Pagan and then the LM test is significant, then it means that we are going to have the random effect model. But of course, if it is insignificant, then our pooled OLS, when I say OLS, I mean pooled OLS, our pooled OLS. But of course, when you do that and it even tells you that the random effect is good, even if the random effect is good, all right, even if that is good, we still need to test for the battle between fixed effect and random effect. We still need to do that. Okay, so Let's go and do this LM testing. Well, I won't do it because of time. I won't do it. I'll just tell you. Okay. So when you go and do this PLM test with a POLS, okay, this is a test. So you do PLM tests for POLS, you do PLM tests for the random. Okay. And when you do that, you're going to get this result. Well, maybe I got to do it. What do you guys say? I should just run it so that you see how it's actually working. So let me just take it. This is it. This is it. Okay. So let's run this. Okay. This is a Lagrange test, multiplier test for balance panel. And you can see that the result is significant. Okay. And it's even telling you that. And then we run for the random effect. Okay. So you can see the PLM test you do for both. And then we can see that the result is significant. So when you have a significant result like this, for both of them, then you have what? You have the random effect as the winner. So in this case that we have, okay, we reject the null hypothesis and say that the random effect model should be estimated. But of course, you have to now go ahead and do the random effect test and then the fixed effect test. Now, watch the last one. And this is beautiful because what these things are doing is that, oh, by the way, what I just did, I could have done it like this. Let me just show you. I could have done it like, let me try this one. I could have done it like WRE, then I bring a comma, and then I do the POLS. Okay. I bring a comma, I do the W POLS. Let me see this. Okay. So this argument, I think is the next one that will. Oops. Okay. So we have the random effect winning in one section when I compared it with the pooled OLS. And then when I compared the fixed effect and the random effect, you guys will remember that the fixed effect was a winner. Now the very last one, and I won't do that one. Okay, that one is checking between fixed effect and pooled OLS. Okay, so this LM test for fixed effect and pooled OLS is specifically designed for that. When you do that for fixed effect, this is our fixed effect model, and this is our pooled OLS model. You will get this. Okay. The null hypothesis will always say that, what do you call it? It is a pooled OLS. The pooled OLS. That's what the null would say. That is a pooled OLS. But now here, when you check the p-value is what? Is 0. So it means that it's not the pooled. We reject the null hypothesis and say that it is a fixed effect. So watch it. Fixed effect. What fixed effect is stronger than pooled OLS. Random effect is stronger than pooled OLS. And now we battle between fixed effect and random effect, and fixed effect is better than random effect, which we have gone through all of these tests. So on the basis of this, you can now say that this model will go for fixed effect. And you can use a fixed effect and put all the models together. So I'm going to do that now, and now tell you how your final result would look like. Let's put all the models together. Every one of them, every one of them, every one of them. So I'm going to activate the Stargazer and then run the model this way. Okay. There you go. There you go. This is the beautiful beauty. Now, let me talk about the bottom first. So first of all, at the bottom, it tells you about, let me make it smaller because this information is quite loaded. There's a lot of information in here. So sometimes when your pen is too big, you don't see. But you can see that the information is just absolutely loaded. There you go. So observations, some of the observations we take, some will make it unbalanced, some will make it balanced. The R square is running throughout each model. The F statistic is running throughout each model. Okay, so let's go up and see the models that we've estimated. I've estimated so many models, okay? And you can remove some, add some, depending on which one you want to do it. Let me just make it smaller. Okay. So when you look at the model, it's so small that if you don't take it, you don't even see. Okay. But okay, so you can see that the first one is a, oh, that's number 8. Okay, so the first one here is a POLS. And that will tell you which variables are significant, which are not significant, and all of that. The fixed difference model is the next one, the fixed difference. Remember that one, all time varying variables were omitted. Okay, then you have the fixed effect model. Okay. And again, those ones to time varying variables were omitted. The random effects is what you have there. The two-way, the fixed effect, which is only when you're only considering time, okay, time element, that one is there. I wish I can remove that one so that I'll rerun the whole thing again. But that's good. And then this is the two-way fixed effect model. And then I just want to make this one smaller again so that you see the robust fixed effect. I like that. I think this is the last part, so that's good. So if you look at the robust test, so this is the robust fixed effect, and then the robust newer west. They are looking good. Okay. So I have just one question for you guys. Okay. Given all that we've done, okay, looking at some of the interesting things that we have here, which model would you have gone for? Okay, based on this. And I don't need your explanation because everybody will have this explanation. But based on this, if we were to select 2 models, okay, that you are going to base your interpretations on, the first one and the second one. You have the POLS, you have the first difference, you have the fixed effects without any correction, you have the random effect without any correction, you have the time fixed effect, the two ways fixed effect, that's both time and individual. You have the robust fixed effect, and then you have the robust newer west POLS. Okay. Which one would you have gone for? You can raise a hand and now tell me. Speak. Okay. You can raise a hand and tell me, which model would you have gone for? Who is bold enough to bail everyone? Who is bold enough to bail everyone? Which model would you have selected? Okay, let me see somebody's statement. The person says robust fixed effect and random effects. That is Gabriel's answer. Robust fixed effect and random effect. So that is what he says. Okay, now you will bring all of this, but which one will you base your story on is what I'm asking. The 2 that you will base your interpretations, your everything, your story, and all those things on. That's what I'm asking. Which one would you have? Okay, so Gabriel, you got 1 correct, 1 wrong. Which model? Somebody says 7 and 8. 7 and 8. 7 and 8. Okay. Which model would you have based your results on? Let me see another person's answer. 7 and 8. Have you checked the coefficient? As you are mentioning them, by the way, are you checking the coefficient? Are you checking the coefficient whilst you are mentioning them? Okay, because you are not. Somebody give me the right answer. Who gave me that? Who gave me Loretta? Loretta, that was the perfect answer. The answer is the one that Loretta has given right there. That is an excellent answer demonstrated right there. So all of you can see her answer she's given. That is, those 2 models are what you got to use. And the reason is because the 7 and 8 are the same. That's it. So you don't have to go and use the same 7 and 8. They are the same. You check it carefully. You will notice that they are the same. Okay. So if they are the same, why would you want to use the same thing? They're the same. They're the same. By the way, if you use a robust fixed effect, which is the first one to use, that all of you got it correct, the 7, okay, model 7. If you use that robust, you will notice that inflation by the year 1987, inflation has increased by 93%, if I'm not mistaken. Instead of by the 17% that the POLS actually intimated. Okay, so that's an interesting thing. It means the nominal value of the salaries have gone up significantly. Okay. But the thing is that you will not get anything to say about your ethnicity if you have to use that. That is why the one that Loretta mentioned is a very, very powerful point, because she's really, really studied the thing. You cannot use a random effect as anything. The random effect, if you check even the time. If you check the times, the dummy variables, the time dummies, you see that there are none of them is significant in the random effect. And the random effects were to be, away from the fixed effect anyway, because the random effect was intended to correct the pooled OLS, and yet, it's been rejected by the fixed effect in this context. Okay. You look at something like married, okay, you can see that when you are married, you get, that will increase your income by about 11 percentage points than if you were not married. You have that there. Okay. Now, random effect will tell you that will do it by about 6 percentage points, and that model wasn't selected. It wasn't selected in the first. The fixed effect says 4%. Oh, yeah, the fixed effect says about 5%. But that model was a choice of the Hausman specification. Okay, that was a choice of Hausman specification. So that's it. That is how you got to analyze your work. And then from there, the rest will be writing, literature. Okay. Writing your results and then juxtaposing your results with what other authors have done. Check yours against theirs. Okay? Once you say that this is significant, this thing was also found by A and B in their paper in 1968, and then they were able to conclude the same thing. This is where you juxtapose your papers and all of that. Fantastic work. If a person is doing panel data and is not using any of these panel data models, the person has a bit of a problem. That's the first thing. The second thing is that if you're using a panel data model and you don't correct for unobserved heterogeneity, and by using fixed effect and random effect, already you are correcting for this. The person has to handle these things like that. All right, ladies and gentlemen, that brings us to the end of the entire